side panels and grooves. Crotch for days! Next thing we need to do is add a groove into our legs and these rails. So you have to think strategically about this. I try to make it so that we don't have to do multiple tool setups. So normally if I make a groove in a rail like this, especially if it goes all the way through, the perfect tool for that is something like the table saw, because even if you just use a regular standard blade, just a couple of passes, turn it around, you get a perfectly centered groove. The problem is I can't do the groove in my legs that way because it's a stopped groove. So I would have to use my router. So yeah, you can do that, but you're gonna have to make sure that you set that router up perfectly so that it lines up with the groove that you made in here. Well, if we can find a way to use a router for all of this, we could just have a setup just like this guy right here with a 1/4 inch bit and an edge guide. And if we reference from this inside edge right here, when we do the rail, we reference from this edge. When we do the leg, we reference from this edge. We can be pretty well assured that that groove is going to be consistent as it goes all the way around. So that's what we're going to do. Now the legs shouldn't be too difficult. We'll put that aside, and I want to focus on the rails first. Now I'm going to reference from my inside surface. Remember my tape with my labels, that's my outside surface. So my inside surface, and I'm going to couple this with something that's going to help us balance that router. Trying to balance a router on a 3/4 inch piece with an edge guide, it's a little bit dicey, kind of a sketchy thing to do. So we are going to put it up against a milled up 2x4 with a nice flat face and a nice straight edge on it. And then we're going to put this into the leg vise. Oh, and by the way, I have already drawn a 1/4 inch groove on here. I just marked in a 1/4 inch on one side, 1/4 inch on the other side, and that gives me some pencil lines showing me where that groove is going to be. And we'll use that to set up the router in a minute. So let's get this guy into the leg vise. This will take a little bit of finessing. By finessing, I mean beating it with a hammer until it's where it needs to be. Oh yeah. It's pretty flush. Snug it up a little bit. And now I'm going to set up my edge guide. So I do have a 1/4 inch up spiral bit in here, and I'm just going to set the distance from the bit to our fence and make sure that lines up as close as I can get with my two lines. If it's not absolutely perfect, it's not the end of the world because we're referencing from the same face every time. So the panel can still fit in there. We just may have a slightly off-centered groove, but we're going to aim for the center. All right, I want to show you guys a cool little trick to set the depth here. We need to go about a 1/4 inch in depth. And if you have a little brass block or anything that you know to be exactly a 1/4 inch, even a router bit or a drill bit, you can use that as a little gauge here. So first thing I'm going to do is bottom out my bit. Once it makes contact with the work, I can stop right there. Okay, that's my 0 point, right? So we want to go a 1/4 inch further than that. So an easy way to do it is find your nearest little turret stop there. Drop the 1/4 inch gauge in place and bring this guy down to make contact. And now we can tighten it up right there. What that's going to do is limit our travel another 1/4 inch. You're going to get another 1/4 inch out of it. And we have only a 1/4 inch to travel before we hit this post. So that is the setting we need, and we don't have to do any measuring. All right, let's hook up the dust collection and get going. All right, so we got another one of these, 3 more to do, same exact way. Oy. Next! Now for the groove that goes into the leg, what you can do is drop one of your rails in place, and then you can draw with a pencil inside here to get the bottom of that groove, and that's really where the groove has to start on this one. But let's take a look at where that puts us. You can see the pencil line is almost into that mortise, so what we're going to do is just drop the bit right into the mortise and go straight on through, and we're essentially going to go from mortise to mortise with that groove. And now the great thing about the way we've done this is once I'm in the vise here and I drop down into that mortise, go straight across, we don't have to make any changes to the edge guide, and we know that that groove is exactly where it needs to be. And one thing I'll point out here, once this is done, you can see why I wasn't too concerned about it. The groove goes all the way through, but this mortise is a lot deeper than that 1/4 inch groove. So there's still plenty of mortise wall left here on this side to keep that mortise and the tenon that goes into it nice and stable. So don't worry about the fact that we're going into the mortises. All right, next up, we need to add side panels, 1/4 inch side panels. So in order to know what size that panel is gonna be, we should probably do a little bit of a dry assembly, and we could just get our measurements from here. Of course, the plan will give you those numbers, but this is one of those points. It happens anytime you have a set of plans where you actually need to disregard the plans and get the information right from the project itself. Now, they should be the same, but ultimately, real life changes things, and that means you might have a dimension that's a little bit different than what the plans call for. So all we need to do to measure for the panel, when we have our subassembly here, is to just measure the distance between the legs and the distance between the rails, and then we have to add the amount for our groove. So this is actually kind of a subtle point. If we're going with a solid wood panel, we should allow room for expansion across the grain. Vertically, we can get pretty tight with that, don't have to worry about it. So it's a good idea to know exactly what the dimensions of that groove is, because you need to add that to the size of the panel and then consider wood movement. So I want to show you something here. I've actually got a groove that maybe is a little bit over a 1/4 inch. I'm going to turn this to the side so you can see what I'm talking about. Now, I won't say this was intentional, but it's just the way things turned out. So you see my 1/4 inch line right there? When I put my straight edge into the groove, I go just a little bit past that 1/4 inch, which tells me my groove is just a little bit deeper than a 1/4 inch. And that's good, because if I do my math and I just consider this groove a 1/4 inch, then when I do all that math, everything comes out just a little bit shy, and that's what we want to allow for expansion. So I'm going to take my distance, I'm going to add an even 1/4 inch, knowing my groove is going to give me a little bit of room to breathe. All right, now it's probably worth going over the math on here, because I've got a very realistic situation that you might confront. So the width that I measured is actually 17 3/16 of an inch. We were supposed to hit 17 1/4, but most of the time when I do these things, I'll measure 17 1/4, make the cut, set my stop block, and I only care that all four are the same. As long as it's close to 17 1/4, I'm good. So I'm actually just a little bit under, and that's something you might confront too. All right, so we need to add in our groove, which is a 1/4 inch, and then another 1/4 inch for the other side. That's a total of a 1/2 inch. And that whole thing equals 17 11/16. That's our width. Okay, on the other dimension, I actually was able to hit my number, and that's 18 inches. So this one's super easy. I'm going to add the 1/4 and the 1/4. That's a total of a 1/2, right? So we could just say 18 1/2 inches for the length of the panel. And again, I'm keeping in mind that I have a little bit, just a little bit of extra depth in there, more than for the 1/4 inch dimension, to give me that room for expansion. If you have a groove that's exactly a 1/4 inch, you're going to want to take this dimension and maybe subtract a 1/16 from it when you get your panel width to allow for that movement. Now, in a lot of cases for the panel, you're probably going to have to take 4/4 stock and either plane it down or resaw it down to a 1/4 inch and maybe do a panel glue up. We may have some panel glue ups to do later, so we'll be able to cover that technique, but I've got a very unique opportunity here. My buddy Tim was able to resaw a couple of crotchy walnut boards here that have just an amazing grain pattern. And take a look at this. So we pull them apart. We got some cracks and stuff in there to deal with, but we have ways of dealing with that. But I think these would make absolutely gorgeous side panels. Now, these were originally cut because I thought I was going to use them as front doors, but the plans changed. So with the dimension that we have to work with here, I have no choice but to plane it down at this point. I don't have a way to resaw it, so that's what we're going to do. But they're already about a 1/2 inch, so we're not losing a ton of material. So we're going to have to strategize. These are not square. I have no reference surfaces, so I'm going to have to make them. And I want to make sure that these patterns that are on here actually look the way I want them to look and are centered in my design. Or maybe I don't want them centered. But the point is I have to decide what the reference points are and make them. All right, so we're going to do a little bit of drawing on here and try to square this thing up. So here's how I'm going to do this. I like this pattern here in the middle, and I think I want that to be the center. And we'll do some kind of a fill on that here, but I'm looking at this pattern. Don't be confused by the lines. This is part of the milling process as it was flattened, so ignore those. So I'm just kind of looking at this pattern right here and trying to find the middle, and it is actually where those cracks are. So I'm gonna try to draw a straight line here because I do have to plane a lot of this stock away, no problem using a Sharpie. I'm gonna draw that line, and then now I wanna go an equal distance to each side of that line to establish the width of my panel. In my case, that's 9 inches in each direction. That's a little bit overage for this panel. We'll cut it down to final size later. About 9, somewhere in this area here, and another 9 this way, somewhere in that area there. So we need to have a square bottom. I don't necessarily just want to straighten this out randomly. I want to make sure this straight line is square to my center line that I drew. So I'm going to get a square, drop it on my line, and draw the bottom of the panel. And now we continue that all the way across. And we should be pretty close to nice and square here. Now I can take my square onto my bottom line, something like that, and now I can draw that outer dimension. Close enough. Okay, so that's enough information that if I just try to, with whatever tool I want to use, start cutting to these lines, I can get pretty close to the squareness of my panel and then just start to clean it up like any other panel. We're going to repeat this process on this other piece, and then we got another crack here, right? So we're going to call that our center. So as we run this line down the center, we'll just repeat this whole process, and in the end, the two panels should look fairly well matched, especially since they're both on the sides and you won't ever really see them at the same time. It's going to be close enough. We're just centering that pattern. So the way I'm going to cut this is at the workbench. All I really need is to find a way to make 2 edges square to one another, and then I could just use the table saw for the other 2. So a track saw is a great solution for this. I'm going to go on my line and make my first cut. So I've got a nice straight edge for reference, and my track has one of these little square dealy bobs. Slide that on, and that's going to keep me nice and square to make this second cut. Excuse me. Here we go. Beautiful. Now we have 1 square corner. We'll do this on the other panel as well. Looking good. So here at the table saw now, we can make the other 2 cuts. And at this point, if you wanted to, you could make the measurements exactly those final dimensions so that we match the measurements we took from our project. All right, so as I was about to start planing this down, I had just kind of second guessing myself. These are kind of fragile panels in a sense with this crack here. I am getting a little bit concerned about what happens when we go to a 1/4 inch, and it's also an awful lot of material to get rid of. Kind of don't want to waste it. So I think I'm going to change gears here. This is going to be put into the plans as kind of an option because you could still do the 1/4 inch panel. It's going to work fine. But we're going to do something that actually will come into play later when we do our internal dividers. We're going to do a rabbeted 1/2 inch panel. That's going to allow me to keep the thickness that I want, but by putting a rabbet around the edge, it's going to give me a 1/4 inch tongue that can then go into the 1/4 inch groove. So nothing has to change with our frame, but we'll be making these just a little bit differently to conserve the material. So they're still oversized. I still need to plane them down a little bit, just not down to a 1/4 inch. So before I get down to my final thickness, I figure I'd just kind of run you through the process here. I need to fill this because that doesn't look real good and I want it to be as stable as it can be. Traditionally, I would just use epoxy, maybe with some black dye in it, but lately I've been trying some different things. This is some kind of a poly material. It's a 2-part mixture, no VOC product, and so far so good. I mean, it's definitely not the same as epoxy, but it's hard enough and seems to dry very quickly. You got about 3 minutes to work with it, and then you have about 20 minutes until you can sand. So if you are tired of waiting for epoxy, this might be a good product for you. So the idea is just like epoxy, you squeeze out the right size turd. Thank you. And they do sell it in different colors. And try and squeeze out a similar sized turd. Then we're gonna mix them up. So my goal here, I don't want to spread it too crazy. I don't want to get it into the grain, just in the center area. We're going to drive it down into that crack in a couple of passes here. I don't think, given the thickness of this stuff, I don't think it's going all the way through. to the other side. So that's looking pretty good. I'm going to flip it over and seal from this side. Now I got a little crack up there that I'm going to tend to. And that you could definitely use like CA glue to fill if you wanted to. I'm just going to go ahead and continue with the black stuff here. Okay, so I'm going to set that aside to dry. I have enough here to do my other panel. I was lamenting recently about waiting for epoxy and how it kind of grinds a project to a halt when you have to wait for an epoxy pour, not fill, to dry. And this was recommended by Mike Coffey from Coffey Custom Builds. And he says he uses a lot of this stuff, so figured it was worth a shot. I guess by the end of this, I'll let you know if I concur with that recommendation. All right, so we actually give it about a half an hour to dry. Feels plenty hard to me. So before I send this back for the final pass through the planer, I'm actually going to clean up both sides. I don't want my blades to hit this hard stuff. By the way, you could see that staining around here. We'd have to sand or at least scrape or do something to get rid of that. And if this were the finished dimension, that might be kind of a pain in the butt and might actually put a little divot in there. So that's why I'm doing it this way and planing after the fill. Right, so to cut the rabbets in these panels, I'm going to use the table saw. I've got a sacrificial fence installed and a dado stack. The dado stack is actually over 1/4 inch. Now we know we need to be about 1/4 inch wide, and we're going to have to raise the blade about 1/4 inch. So why did I go with something that's bigger than 1/4 inch in the blade? Well, when you're doing a rabbet that's all the way to the edge of a workpiece, you got to be real careful with that. If I went with exactly 1/4 inch, it's going to be pretty tough to get that blade at the exact point of the end of the fence so that we get a full 1/4 inch rabbet all the way around. So to make that a little bit easier, and also to make things a little bit more safe with a saw stop with the possibility of metal contact with the blade, what we're going to do is go oversize with the dado and then bury just a small portion of that blade into the sacrificial fence where it won't set off the saw stop, but leaves me with a nice clean 1/4 inch spacing that I could just run my panels across and get that done. Now, I don't trust this to do this right away on my actual panels. I do have a scrap board, and I'm going to see if I can get pretty close to 1/4 by 1/4 inch, and then we'll be able to apply that to our panels. I will say, I'm going to keep the blade a little bit low so that the tongue is just a little bit thicker than it needs to be, because I need to verify on our actual panels that it's going to fit in the groove. If I overcut it, I can't put the wood back. All right, let's make a test cut. Before we actually make the cut, you want to make sure you designate one of your faces as your outside face, right? So pick which side of your panel looks the best. That's facing out. The rabbet cut is on the inside face, and you'll see with the final installation why we do that. We really don't want to see a gap where that rabbet is, and that's surely going to happen on the inside. We don't care about the inside, it'll be fine. So we'll get a couple of paddles and we'll press it through. Now, one habit I have with an operation like this, I tend to really push in pretty hard on my fence. Most fences are fine with this, and it's not a flaw of this fence, it's just the way these fences are built. If you push really hard at the end of this fence, you can actually cause a little bit of deflection. So let me show you a little tip, something that I do periodically on cuts like this. I like to add a magnet on this side, sometimes 2 magnets just to be safe. And that actually will give me just a little bit more resistance from any kind of deflection at the end. If you don't have these stupid expensive magnets, I don't know why they're so expensive, but if you don't have these, you could always go with a real no-frills solution with a block of wood. Total no frills here, just get a 2x4, clamp it to the extension wing of your table saw or the outfeed table, clamp it on the end, and that'll effectively do the same thing. And it's just a little bit of an insurance policy. I've done this before where I skip this step and I find out that my rabbet that I'm cutting kind of wavers in a little bit because of that little tiny bit of deflection. Now you saw that we tested the tongue's fit. A note about that is if you have a nice little snug fit, we kind of do at this point, it's a little bit snug. Well, we haven't done a final sanding on this face yet. So after we do that sanding, we're likely going to wind up with a slightly thinner tongue. So I wouldn't really stress about it. You kind of want that snug fit. And the way we're going to test whether or not the rabbet width, I guess you would call it, the way we're going to test if it fits correctly is, well, first, this guy is going to be installed like so, right? This is the inside face, and it'll be installed in our side subassembly as we see it here. But all we have to do is flip this guy around. And if this inner rabbet section drops down into the square, we know we've at least cut enough. Let's see if we have any wiggle room, because we still need that room for movement. Top to bottom, I got a little bit, not too worried about it, because we're not worried about expansion in that direction. But side to side, you see that little bit of movement there? That's exactly what we want. That tells me that the panel is going to be free to move if it expands or contracts over the course of seasons. All right, so now we can do that little bit of sanding on the panel, and we can do a final dry assembly. Now after I've done the sanding, this is about as much, as thin as these tongues are going to get, so it's a good time to do a final test and make sure all the tongues are sized appropriately. Now that's pretty good. I mean, that's ideal. You want it to go together without a hammer, but also, a little bit of a push and it will fall apart. But there's really not that much to that tongue. That's really what you would call like a friction fit. So that one's good. Let's see how we are on the bottom of the panel. All right, this one. Okay, that might go, but that seems just a little bit snug. I feel like it's a little more snug in the center than it is on the outsides. So we could very easily remedy this with a shoulder plane. Shoulder plane is just the perfect tool for this because the blade comes all the way out to the edge and it allows you to ride nice and square up against a rabbet like this. I'm gonna try to focus just on the center for the most part. There you go. So do that on both panels, all 8 of these edges. All right, so the last thing we really need to do at this point is a dry assembly, bringing the panel to the legs and the rails. I think the easiest way to do this, because it's a good snug fit, is to get our rails onto the panel first. Try to find the center point here. Okay, lower rail, then I'll bring in my upper rail. Good. All right, so this is my outside face. I'm going to apply this to my leg, get those tenons in. You want to be careful as you you start to get the panel close to your groove. If something is just slightly off, you may wind up actually crushing the corners. So take your time and tap those rails in place. Now I'm at the point where the panel is starting to sink, so I'm going to be a little bit more careful here. It's bottomed out. And now for the other guy. So you can see from the outside here, we kind of have the look we're after. The one thing you can't really tell is the movement from side to side. If those grooves are snug, you're not going to really be able to move the panel. But as long as you know that those gaps are there, you can be assured that if there's any kind of expansion, it's going to have no problem moving as long as we don't glue into the rail. We don't need to, we'll just let it float. So the outside is looking the way I want it to look, but it's kind of nice. Even with the square, unshaped legs, that's really nice. On the inside, what we see is a flat flush surface, and if you look closely you could see gaps around the outside. We need those gaps. Those are the expansion gaps, but that's also why that's to the inside. This goes back to why the rabbet was put on the inside face, not on the outside face. You want to see these gaps on the inside. So these are 2 sub-assemblies at this point, and we've got a lot more that we need to do. There's other details we need to add to this, but for now, we could leave these on the side and get back to them later. There she blows! Next time on The Wood Whisperer. And once all the joinery is cut, I do recommend doing a dry assembly. The inside dividers here, these little rails, their position, you know, this way or that way, isn't quite as critical. The outside ones, they are critical.